All right, so in today's lesson, we're going to talk about how to do factoring for something called a complex ABC. Okay, so before we get into the weeds of actually doing some factoring, we're going to go over probably one of the biggest things you might mess up on as a student when you're doing these factoring problems. And sometimes it's not even really with just actually doing the factoring, it's that you're picking the wrong method. So we're going to draw a clear distinction right now between what makes something a complex ABC versus what we saw yesterday, right? Like remember yesterday we were dealing with simple ABCs. How do I tell the difference between the two? Because depending on which one we are, we're going to use a completely different method, okay? So my question to you, what makes something a simple ABC? Okay. Well, both of them have these three terms, ax squared, bx, and c, where a, b, and c represent numbers. But the real thing that makes this a simple ABC is this. A is equal to 1, okay? So that number right out in front of this whole entire expression is always going to be 1 if it's a simple ABC, okay? That's how you can tell the difference. Where the ones we're going to look at today, complex ABCs, they still have those three terms, but now A is greater than 1. Okay, so maybe it might be like 5 or 2 or 10, so that the number that's in place for A is now going to be bigger than 1, and it's the huge way that you distinguish which method you're going to use. Okay, so let me just make that really, really clear because I think that's one of the areas that um, I don't know, people mess up on because they're using the wrong method. So make sure you figure out whether your problem is complex or simple and you're using the correct method for it. All right, so all of that aside, the method I'm about to teach you right now is probably going to be different from the method that your Algebra 2 teacher might teach you. There are so many different ways that you can go about factoring, okay? The method I'm going to show you right now, because I've taught a lot of different ways to do factoring. This method is hands down the fastest way to factor, okay? Hands down the fastest way I've seen so far. And I think it's probably one of the easiest ways as well. Okay, so if you can keep this in your arsenal, if you can remember this when you enter Algebra 2, this is going to be a huge help for factoring. Maybe if your teacher teaches it some other way, you'll learn that way. But this is a pretty cool method. So this is called the swing monkey method, something like that. It has a bunch of different names, but the monkey method. Okay. So basically, what's going to happen is I'll end up kind of swinging some numbers back and forth, and you'll see what that looks like in just a second. So the first number I'm going to swing quotation marks, uh, is that number A, and I'll swing that to the back. And what that means here, this particular time that I'm swinging, is really I'm just multiplying, okay? So I'm just taking this 5 that's out in front, don't worry about the x squared, but just the 5, and I'm going to multiply that by 3, okay? So this is how we're going to start out every problem. Just take that number in the front, multiply it by the number in the back. So if we do that, we can now rewrite this because we moved it back here. It's x squared, so now the 5 is gone. So it's x squared plus 8x plus 15. And all of a sudden, we took this problem that was actually going to be pretty challenging as a complex ABC, and we turned it into a much easier simple ABC. Because now our A is equal to 1. There's just a 1 there. All right, well, we know how to factor simple ABCs. Let's go ahead and do that. So let's see if you can remember the steps that I need to do first. What's the first thing I have to do with a simple ABC? So I'm going to focus on C, which is 15. Hold that off to the side. And then I need to find pairs of numbers that multiply to make positive 15, right? So let's see, that would be always, I'm going to put 1 and then the number itself, so 1 and 15. Let's see, if I was to test out 2, what's going to happen, right? So let's see, 15 divided by 2, nope, not going to work. I get 7.5. That has a decimal. Decimals are not allowed. So 2 is not going to be a factor. Let's try 3. All right, that's definitely going to work because 15 divided by 3 gives me 5. And then if I was to test out 4, 4 doesn't work either. And really that's where I would stop, okay? Because we get to a place where they start overlapping again. So these are our only 2 pairs of numbers that we have to work with, okay? All right, so now that we have that, we know we're going to factor into 2 binomials. What do I put inside of them? Do you remember how this works? Okay. Well, for both of them, the first term is going to be x and x, right? Now what do I do? Okay, so hopefully if you remember from the last video, I need to figure out which pair of numbers adds up to make b. B, the number that's standing in place for b, okay, which is 8 in this problem. All right, so that's definitely going to be 3 and 5, right? Like positive 3 and positive 5 definitely multiply. They multiply to make positive 15, and they add together to make positive 8. So bingo, put those numbers in. Actually, let me write those in a different color. So plus 3, plus 5, okay? All right, so since this is a complex ABC problem, at the end of this, there's a little twist at the end. So I know that we changed to a simple ABC and we did the normal factoring that we were supposed to do, but since this was actually a complex ABC at the beginning, there's a little thing we have to do at the end, okay? So the monkey method says that at the end of doing all of this, we're going to take that number that we swung over, that 5, that A that's out in front, and since we multiplied it here, now we're going to go in and we're going to reverse that. We're going to divide. So both this number 3 and this number 5, we're going to go in and divide those by 5, that number that I swung over, okay? So first I'm multiplying, and then I go back in and I reverse it, and I'm doing division, okay? All right, so what's going to happen is when you're dividing these numbers, if they make any decimal at all, so for example, like when I do 3 divided by 5, that makes 0.6. That is not going to work. If this creates a decimal, then what I'm going to do is I'm going to swing that 5 up to the front, okay? So now I'm going to get something like this for my answer. So I swung the 5 up to the front because when I divided here, this gave me a decimal. It's the whole reason I'm swinging it up to the front. So now I'm going to write this as 5x plus 3. Beautiful. Over here, now since this 5 divided by 5, that doesn't create a decimal, that's just 1. Okay, that came out cleanly. So since this came out cleanly, I am not going to swing it over to the front. So now I would just write this as x plus 1. Okay? And that is actually my answer. I'm done. Cool. So let me just reiterate the reason we decided to swing this over and the reason we didn't swing this one over. So the reason we swung this one over is because when we did 3 divided by 5, that made a decimal. I don't like decimals, so that's why we swung them over to the front. Here, 5 divided by 5 just made 1. There was no decimal, so I just do that division and I get my answer. Okay? Let's try one more example of this. Okay, first step. I gotta swing this number all the way over here. That means I'm multiplying. So now if I rewrite this, I have k squared minus 7k plus 6. Perfect. Now I have a simple ABC that I can work with and factor away. So I'll take the 6, pull it off to the side, think of numbers that multiply to make 6, and that would be 1 and 6 and 2 and 3. So 1 times 6 and 2 times 3. All right, this is going to factor into two binomials. They both start with k. And then I have to figure out which of these pairs of numbers is going to add up. They have to add up to make -7. Okay. Well, right now this 1 and 6 that adds to make 7, and 2 and 3 that adds to make 5. So neither of those right now are going to work. But if you remember from the last video, recall that if we have a negative and a negative, those still multiply to make a positive. So what if we change these both to negative and see which one of those pairs works then? So hopefully you can see right away that -1 and -6, those would add to make -7. Bingo, I found the pair that I need. Okay, so I'll just take those, double check again. Yep, those multiply to make +6, and they add to make -7. Go ahead and put those in. So -1 and -6. All right, so if this was actually a simple ABC problem, this is where I would stop, right? But since this is a complex ABC, I have to go back because I've multiplied at the beginning, and I have to perform some division. Okay, so I'm going to divide by that number that I multiplied by. So let's go in and divide this number by 2, and then this number by 2 as well. So again, I have to go back and I'm doing some division. Okay, so let's see what we get here. So -1, include that sign. So -1 divided by 2, that gives me a -0.5 decimal, right? That's not going to work. So since this is a decimal, I have to swing this number to the front. So let's see, I get 2k minus 1. Okay? All right, so now let's try this one. -6 divided by 2. Well, that's -3. That comes out cleanly. We're good. We don't have to swing this number to the front. So I can just write this as k minus 3. Awesome. So that would be my answer. I'll do one final example of this. And really, what I would encourage you to do is pause the video, see if you can solve this on your own, and then unpause it and see if you got the same thing that I did, okay? So, first step, I gotta take A, swing it over to the back, so that means I'm multiplying. And I'm gonna rewrite this as x squared minus 3x minus 10. Makes -10. Alright, so then I take my -10, pull them off to the side. Remember, first when I'm finding those pairs of numbers, I'm going to ignore the negative that is there. Okay, so let's just think of 1 times 10. And then if I have 2 times 5, that would work. And there's actually no other pairs of numbers that multiply to make 10. Those would be the only two pairs. Okay, so I'm going to factor this into my two binomials. Okay, x and x. And then which one of these would add to make -3? So remember now since this 10 is negative, if you recall from the last video, since 10 is negative, one of the numbers in each of the pairs needs to be negative. So we can go through the first pair and test it out and see. So let's see if we make one negative. Add that together, that would make +9. Not going to work. What if we made 10 negative? -9. So that pair doesn't work at all. So it has to be this one. Which number is the one that should be negative? Okay, so hopefully you chose 5. 5 needs to be negative. 2 needs to be positive. And let me just double check again before I put it in there. So +2, -5, that multiplies to make -10. Yep. And -5 plus 2 adds to make -3. Wonderful. So now I can go ahead and put those in their place. So I have +2 and -5. Okay, and then the very last step is I have to go back and take that number that I swung over, that I multiplied, and I have to go back in and divide by that number. So I'm going to divide by 10 here and divide by 10. So then I'm doing division again. Okay, so let's see what's going to happen here. So 2 divided by 10, right? That does not come out cleanly. I get 0.2 from that. One thing I'm going to suggest, though, actually before we swing this number over, is I can reduce this fraction a little bit. So what that means is I'm going to go in and I'm actually going to divide both of these numbers by 2. So for example, like if I had 2 over 4, 2/4, it reduces to 1/2. Well, how did I reduce that? I divided both the top and the bottom by 2, and that's how I was able to reduce it. Just as if I had maybe another fraction like 3 over 9, right? That can reduce to 1/3. I go in and I divide both of these numbers by 3, the top and bottom. So what can I reduce this to? Well, it looks like both of them are divisible. I can divide, let me write a better division symbol there. I can divide the numerator by 2, and I can divide the denominator by 2. So let's see what happens once I do that. So divide this by 2, divide this by 2, I get x plus, well, 2 divided by 2 is 1, and then 10 divided by 2 is 5. Okay, so notice I still was not able to change this. It's still 0.2 as it should be. Reducing stuff doesn't change the value of it. But I am definitely going to have to take this number 5 now and swing that over to the front because this created a decimal. So now I'm going to get 5x plus 1 as my answer. Okay, so please make sure this is reduced rather than the other way that you saw it, which is where we had. Okay, so now let's go in and figure out what's happening with the other one. So -5 divided by 10 is also a decimal, so I'm definitely going to need to swing this 10 up to the front. But before I do that, again, like the other problem, I can reduce this a little bit. Okay, so if I divide both the numerator, the top, and the bottom by 5, what does that reduce to? Well, 5 over 10, that's just another way to write 1/2, right? And if I divide, let's see, if I take -5 and divide that by 5, I get -1. And then if I take 10, divide that by 5, I get +2. So hopefully you can see that 5 over 10 reduces to 1/2, and then 2 over 10 reduces to 1/5. Okay, so I'm just reducing my fractions. Still, I gotta swing this up to the front, and now I can write this as 2x minus 1. And that is my final answer. Again, like I showed you guys in just one of the problems yesterday, if you wanted to check your answer, what would you have to do? You would have to go through and multiply all of this. So like I would multiply like 5x times x, 5x times 1, 3 times x, 3 times 1, multiply all that out, and if I got what I started with, which is this 5x squared plus 8x plus 3, then I did everything correctly. So I encourage you to maybe multiply all this out, see if you can double check that this one is correct, and that is how you would do factoring for a complex ABC.